In this video, we are going to be going over the quadratic formula, and in particular, how to use the discriminant to determine the nature of the zeros or roots of a given quadratic equation. So the quadratic equation, if we have a formula, or if we have a quadratic equation that is in the form ax squared plus bx plus c equals 0, with a not equal to 0, then the real solutions, or the solutions to this equation, are given by the quadratic formula, which is x equals opposite b plus or minus square root of b squared minus 4ac all over 2a. This part that's underneath the square root is called the discriminant, and it is important because it tells you the nature of the roots of whatever quadratic equation you are dealing with. So again, the quantity b squared minus 4ac, which is underneath that square root in the quadratic formula, is called the discriminant of the quadratic equation because its value tells you whether the equation has real zeros and how many solutions to expect. The discriminant also tells you how many zeros or x-intercepts the quadratic equation f of x equals ax squared plus bx plus c will have. So if you have a quadratic equation, ax squared plus bx plus c equals 0, if b squared minus 4ac is greater than 0, in other words, if it's positive, there will be two unequal real solutions, and it will have two x-intercepts. If b squared minus 4ac is exactly equal to 0, there is a repeated real solution, also known as a root of multiplicity 2, and so it will have exactly one real solution that basically happens twice. Its graph will have exactly one x-intercept, and it will just touch the x-axis without crossing it. If b squared minus 4ac is less than 0, you end up with a negative sign underneath the square root, so there is no real solution, and there will be no x-intercept. It will, however, have a complex solution. In other words, it will have a solution using the complex numbers. All right, so for these problems, we will just use the discriminant to decide how many zeros each has. And for letter C and D, for these examples, we will also solve the equation and find the zeros. All right, so let's see. For part A, notice we have ax squared plus bx plus c. So a is equal to 1, b is equal to 6, c is equal to 1. Our discriminant is b squared minus 4ac. So this is going to be 6 squared minus 4 times 1 times 1. So this will be 36 minus 4 equals 32. So this is a positive number. It's greater than or equal to 0. So there will be two distinct real roots and two x-intercepts. All right, easy as that. Let's look at B. In this case, again, we have ax squared plus bx plus c. A is equal to 2, b is equal to 5, c is equal to 3. So b squared minus 4ac is equal to 5 squared minus 4 times 2 times 3. So this will be 25 minus 24, which is equal to 1, which again is greater than 0. So similarly, there will be two distinct real roots and two x-intercepts. All right, let's do C, and for C and D we will actually solve and find the roots, but let's start. Notice that A is equal to 4, B is equal to 1, C is equal to 1 in part C. So b squared minus 4ac is equal to 1 squared minus 4 times 4 times 1. So this is equal to 1 minus 16, which is negative 15, which is less than 0. So this has no x-intercepts and no real solutions, but it will have two complex solutions. Let's find those solutions using the quadratic formula. So again, x equals opposite b plus or minus square root of b squared minus 4ac all over 2a. And if we remember, a was equal to 4, b was equal to 1, c was equal to 1. And let's just double check that that is correct, and indeed it is. I'm going to plug in my numbers. I get negative 1 plus or minus, and b squared minus 4ac we already know is negative 15, so I'm just going to put that in here, all over 2 times 4. This ends up being negative 1 plus or minus, and if we have a negative square root, what we can do is change the negative 15 to a positive 15, but bring out the number I. Remember, I is equal to the square root of negative 1. And then 2 times 4 is just 8. Now, the square root of 15 cannot be simplified, and so this is our final answer. There are two possibilities. There are two solutions. There are to the equation 4x squared plus x plus 1 equals 0. That would be negative 1 plus I square root of 15 all divided by 8, or negative 1 minus I square root of 15 all divided by 8. All right, let's do the last one, which is right here. I'm going to erase some of this stuff so we have some more room. And notice that in this case, A is equal to 4, B is equal to 20, C is equal to 25. So our discriminant, b squared minus 4ac, is equal to 20 squared minus 4 times 25. This ends up being 400 minus 400, which is equal to 0. So this will have one real 0 and one x-intercept. Let's use the quadratic formula to find the one real 0. First, I write down my formula, and then I plug in my numbers. So b is equal to 20. So since it's a positive 20, let me make sure I didn't. Yeah, everything's positive there. So this will be negative 20 plus or minus. And we already figured out that b squared minus 4ac is just square root of 0. And then all over 2 times 4. So this ends up being negative 20 plus or minus, and the square root of 0 is just 0. Now this is part of the reason why this will only have one solution, because when we split this into two other possible solutions, you either get negative 20 plus 0 divided by 8, or negative 20 minus 0 divided by 8. Now, in both cases, negative 20 plus 0 is just negative 20 divided by 8. And negative 20 minus 0 is just negative 20 divided by 8. So we have, again, basically you have two solutions, but they're the exact same number. And so we say that it has a 0 of duplicity 2. We're going to get rid of one of those. And this will be our final answer, but we should simplify it. So we divide top and bottom by 4, and we get negative 5 halves. And that is that. And so that is our final solution. And we are done with this problem. All right, hope that was helpful, and we will see you in the next video.